Quit
You
cheating
said-
on me.
Okay, you
We wanna
said
be,
2
let's
liters.
go, yeah, I'm changing my mind. 2200, let's go 2200.
Little much yet.
Yep.
Couldn't we just hold a watch? We just hold a watch up here and you filmed it, then you would
Close.
see.
Right,
time.
exactly, you could do that too.
Like a sweep hand.
Spoken like a true engineer. Stick on a what?
Okay, that's very close.
You got it?
Let me just set it here.
Okay, so one of the things I like to do, oh, he's really getting technical on me.
It's about
So,
1.5.
you want to show the class, all right, we're going to put 2,200 milliliters of water in, so they see how much that is, okay? And then the question is, this is how much we're putting in, and then the question I like to ask the class before we start is, do you think we're going to have any flood issues? Here and down there. So I let them decide and debate that, and some will say, I ask for a show of hands, how many think it's going to flood? How many think it's not going to flood? So you get your mix there. And you know, depending on the kids, some will say it will flood, some won't, so it's a good mixture of what you got going. So anyway, so you kind of do your poll up the front, and what I want the rest of the group to do is to observe as he pours it in, and the experiment starts as soon as he starts pouring. Not when you get the runoff. So as soon as he starts getting the precipitation, the event starts. So there's going to be a while where the readings are going to be the same.
Oh, now you really want nuts, you could do a time lag. You could measure the time from the beginning till you
Right.
actually started getting
So
runoff.
you can do all kinds
Oh,
of crazy
yeah.
stuff. So anyway,
TC path in here while we're at it?
so,
Okay.
so that's what we got. And then the question is it going to flood or not flood? And then the other important thing is to make sure you've got that in the bucket, because I've had cases where it's not in the bucket, and that gets messy in a hurry. But the ultimate goal is we're going to see how much we put in, we're going to see how much runs off, and then the worksheet actually asks you to calculate what your runoff footprint is in the calculation. So that's what you got. And then they also determine what, in our terminology, bank full, flood stage, time of the crest height, how much rain you put in, how much runoff you got. So all those things are on their worksheet that they get into. So anyway, for our first experiment, let's go ahead and everybody's clear on what they got to do, and you just kind of have to make sure that this is lined up over the top of that. And everybody else can watch and observe.
You don't push it to this side. You're trying to get this front edge over that.
I'm just trying to get this so that it rains on the sponges and doesn't.
Okay, you're not trying to
get
line up
full.
exactly with either one. Okay.
No, it just has to be close enough for government. And then for your pouring standpoint, what I tell the kids is pour as fast as you can without it spilling out. So you can pour pretty fast, but you don't want to, do that kind of thing.
Yeah, I don't want to get wet.
Exactly.
You are in the right location here, Paul.
But I want them to pour fairly aggressively because I want a pretty good rainfall event. So if they taper off too much, then it's going to affect your
Right, if it gets
hydrograph.
down where it's not coming through consistently.
Yeah,
Okay.
so you really want to pour pretty fastly. So given this scenario, how many think it's going to flood?
You got it set up.
Okay, I have stacked the cards. So
Yes.
no, if it does flood, then we got to rethink how much water we're putting in because it's not supposed to. So whenever and like I say, when you start pouring, that's when the timing starts, and that's when you start taking your readings. So we got our first
Well,
reading.
is zero, well,
Base
whatever
flow.
it's
Yep,
calibrated.
5.01.
And there's somebody taking the numbers
I'm
out
taking
there
them here,
too.
too.
I
Speak
know.
loud,
You
Ken.
Yeah,
gotta-
so you have to
gotta
call out the number so you can hear them back there.
Ready?
You tell me
Normally you wouldn't be that back that
Set,
far.
go.
Go.
Read.
5.01.
Okay, you see the rain coming down. We haven't reached saturation yet. Now we're
Read.
getting some base flow.
Same.
Nothing?
There's your wave. There's
Read.
your climatic wave.
5.02.
Oh, beautiful.
Read.
5.02.
Read.
5.02 and a half.
Read.
5.02.
Watch it from your window.
Read.
5.01.
Guess we're gonna get 2.2.
Read.
5.01.
Okay, so basically we're pretty much done. So you can tell where I draw the experiment is when it really pretty much stops flowing. So now the fun thing is, the kids, do we observe any flooding? No, we didn't have any flooding. So you can talk about, why didn't we have flooding, so you can get into those issues. But now what I want to do is take this down here. Who's going to measure my runoff? So I had some volunteer down there who's going to measure my runoff.
Well, you should have quickly.
Well, you got to pour it
written
back in there. I want to
See how
quantify
much
it.
water's still there. Oh, you're gonna have some. Oh, we're gonna have storage in the wetland.
evaporate.
Oh,
higher than the bottom of the pan.
Standard flow, right?
It's below the increment, no.
No record of it.
Maybe 75?
Right. Usually I get around 200.
Oh, it's nowhere near 200.
Right, exactly. So, I mean, that's where you have to adjust your, but that worked because you still had some flow. When it
It's
doesn't
less
work,
than
because we don't have
100.
any flow.
Yeah.
So you had some flow. But the nice visual is the fact that, show where 2,200 milliliters is. Show where that is.
22.
Yeah, so that's what we started with, right?
That's
And
not
so,
even 100.
and that's what ran off. And did we have any flooding? No, we didn't have any flooding. So the question is, where did all that water go? So that leads you into this discussion. So then they talk about storage and sponges and all that kind of stuff. And then you can ask them, well, what if I add another 2,200 milliliters of water on this? What's going to happen?
This time you'll get a flood, and it's even worse
Exactly. So,
conditions.
so it's important because I don't want the kids to think that wetlands are the end-all be-all to
Sure.
stop all flooding, because everything has its limits. So that's another experiment you can do. I usually don't do that, but the kids will pick up on the fact that, yeah, this is pretty wet, and if I add more water to it, then I'm going to get a lot more runoff. So, you know, that's that. You can bring that message into it. So we got that first experiment. We got our data. There's our hydrograph up there, which looks kind of ugly, and it will change as we get more data. But what we want to do now is I want each of you that had an activity to pick your buddy to replace you. So everybody's going to do something different. So just grab somebody different to do your activity.
You got it right?
And what we're going to do,
I have a question for you.
Yes.
I also consider this as forest field.